Thank you, guys. Thank you all for showing up. I mean, we couldn't do this conference without you guys. And today my talk is titled "A Token Walks into a Spa Instead of a Bar." And it's really an authentication talk. But a little bit about me. My name is Kukic, and I work as a developer evangelist for a company called Auth0, where we do authentication, identity, authorization, all the boring stuff that you don't want to do and build yourself. We could kind of take care of all of that for you. And if you have any questions for me, any feedback, you can find me on Twitter at Kukicado. And I hope to connect with you guys. So this talk really is about SPA and Angular in specific security best practices. And really when we think about Angular applications, they live entirely in the browser. They're entirely public. So we really can't have secure data in the browser because anything we put there, a malicious user is going to be able to look into. So any API keys, any data that we don't want users to read, we can't hide it in our Angular application. So when it really comes to Angular security best practices, we don't have any. And the reason for that, again, is because our applications live entirely in the browser. And if we look at how we traditionally build applications, we have our backend that's secure, that's behind a firewall that's totally secure and end users can't get into it. And we have our front end. So we have our application, our server, and I'm using a fictional application called ngThor because we're here in Finland. And everything that happens within this application is secured. Nobody on the outside can understand what's happening. They can't read the code. All they see is what the browser puts out. So when we have a user come into the application, they're going to make a request, and our application is going to validate their request. It's going to say, hey, can this user access this page? And if so, what data should we render for them? And then our application server is actually going to take care of rendering that application, rendering that HTML page, and then it's going to send it to the user. And then when the user requests another page, it's going to go through that same exact process. The server is going to do all the work for us, and we really don't get a good UI experience from this because the page is constantly refreshing. We're doing everything on the back end. So animations, anything fancy we want to do, we really can't do with the traditional authentication flow or traditional application. So that's why we have Angular. And if we look at how we build modern applications, we still have a secured backend that nobody should be able to access, hopefully, and we have our front-end clients. So we have our application, our backend, and typically this is an API that's, we talk to via HTTP requests, and we send JSON data back and forth. Now, depending on your use case, you might send XML or some other data. But for the most part, you're probably going to be talking to an HTTP API, sending JSON data back and forth. So we have our backend that's secured, and then we have our Angular application that's in the browser, that's fully public, and the user and any data in here is going to be public. So we want to ensure that we don't put anything private in here, and anything we put in here, we can just assume that that is going to be readable for everyone. And to make things even a little bit more complex, when we're building modern applications, we're not just thinking of the browser. We're not just thinking of the browser experience. We're also thinking of the mobile experience. So we might want to have a mobile application and maybe go as far as to have an IoT application or connect our app to like a Google Home or an Echo device. And all three of these dummy clients on the front end that are fully public, that are fully accessible, are going to be making requests to our API server. Our API server is going to validate those requests, and it's going to send back the responses. But how do we ensure that our Angular application talking to our backend API can do so in a secure manner, can do so in a way that we trust these requests, and we can transmit private data back and forth? And the answer to that is JSON Web Tokens. And how many of you guys have worked with JSON Web Tokens in the past? Okay, so almost everyone in this room, which is good. How many of you guys actually deeply know how JSON Web Tokens work? Okay, one guy. So if we look at the JSON Web Token standard, RFC 7519, JSON Web Tokens are an open industry standard method for representing claims securely between two parties. And again, this really doesn't tell us much. And we can also look at what a JSON Web Token looks like. Oh, well, it's a string, it has multiple parts, and you know, even this representation, I could walk you through it, but it's really not that interesting because security generally is not an interesting topic. It's a very dry topic. It's something you have to understand, but you really don't want to. You just want it to work. So I thought I would take a slightly different approach and compare JSON Web Tokens to a real world, I guess, token-based scenario that you might run into. So I grew up in Las Vegas, and Las Vegas is the entertainment capital of the world, or so we say. And Las Vegas has a whole bunch of really cool bars, really cool nightclubs, and all of these bars and nightclubs you really can't gain access to unless you're 21 years of age or older. And how do we validate that you're 21 years of age or older? With a driver's license. So here I have a driver's license. This is Thor's driver's license. We're just going to keep that theme going. And let's see how a driver's license is like a JSON Web Token. So we're going to compare the two and see if the analogy sticks. So the first part of a JSON Web Token, as most of you guys surely know, is the header. And let's put our driver's license on the left-hand side and our JSON Web Token on the right. And the header for the driver's license is going to be the fact that it says driver's license on it, so we know what we're looking at, and also that this driver's license is issued by the state of New York. When we look at the header of a JSON Web Token, and remember, this is just a base 64 encoded string, so we can easily decode, you know, this part in red and see what's in it. And when we do that, we get two properties. One is the ALG field, ALG property, which stands for algorithm, which tells us what algorithm was used to sign this JSON Web Token. And then we also have the type, which is, of course, JSON Web Token. So these fields are usually the only ones required in the header. And again, they're just base 64 encoded, so anybody can look at this information. So our analogy of driver's license being like a JSON Web Token kind of stands. And next, if we look at the payload of both of our driver's license and JSON Web Token, let's see if we can keep the analogy going and have it fit. So if we look at the payload of the driver's license, we see the picture of the user, we see their name, their demographic information, their restrictions, and when it comes to getting into bars and nightclubs, probably the most important thing is the date of birth. We want it to be over 21 years of age. When we look at a JSON Web Token, on the other hand, and again, we base 64 the code, the part in blue, we get a JSON object back that has a couple of different fields. So subject is the user ID, their name, Thor, and a property, a Boolean property for you know, whether they're an admin or not, and in this case they are. So again, all of this data is public, so anything you put in a JSON Web Token, anybody can read and decode. So you don't want to put any sensitive information, and you know, I know a lot of you guys are actually using JSON Web Tokens, so please don't put any sensitive information like credit card numbers, social security numbers, any other information that, if it got out in the public, would be disastrous for your organization. So put just the least amount of information in the JSON Web Token as you can to get the job done. So the final part of a JSON Web Token and a driver's license is, of course, its security mechanism. And for the token, we have the signature, and we have something very similar for a driver's license as well. And at least in the United States, the way that we validate that driver's licenses are valid, or you know, they came from the Department of Motor Vehicles, is they have an ultraviolet light hologram embedded on them that is generated when the driver's license is created. And only the Department of Motor Vehicles that issues the driver's license knows which pattern to use, how to embed it on there so that it looks legitimate. And for our JSON Web Token, what we do is we sign the JSON Web Token with a hashing algorithm. In this case, I'm using HMAC SHA-256, taking the header, the payload, and then finally, the HMAC SHA-256 algorithm requires a string password. And the password I'm using here is Loki sucks. So we're going to sign this token. We're going to get that hash in yellow. And now every time we make an authenticated request with this JSON Web Token, we're going to run it through a verification algorithm and try to see if this token was signed with the password Loki sucks. If it wasn't, we're going to know that this token didn't come from us, that somebody is trying, somebody malicious is trying to gain access to our application, and we're going to, send a 401 or a 403 or whatever the correct error protocol is. And if we do verify that this token did come from us, it was signed with the password Loki sucks, then we're going to say, okay, we could trust this token. It probably came from us or a trusted party, and we're going to fulfill that request properly. So I guess our analogy still kind of sticks, and driver's licenses are like JSON Web Tokens. So next, let's see how we use a driver's license in the real world. So Thor comes down and he wants to go to the bar. And since he came from a land far away, he doesn't have any identification. So the smart thing to do is Thor would go to the Department of Motor Vehicles or a government agency that issues identification. He would fill out a form that states who he is. The government would verify him, and then they would issue him a valid driver's license. And this driver's license might be valid for a year or 2 years or whatever, but they would, kind of validate his identity and then issue him a token, a driver's license in this case. And now he would be ready to go to the bar. And when he gets to the bar, the security guard up front would ask him, hey, before you could get in, I need to see your identification. And he would present his driver's license. The security guard would look at the driver's license, scan it with the hologram machine, with the ultraviolet light machine, and see that this identification came from a trusted source, the Department of Motor Vehicles, and he would say, great, you are who you say you are over the age of 21, we validated all this, so you could go into the bar, and now Thor can go into the bar, he'll go up to the bartender and then say, hey, I'd like to buy a beer, and again, he would have to present his identification, the bartender would validate it, run it through the machine again, and if everything checks out, which it should, he would be able to get a beer or 5 or 10 or however much he wants to drink. But knowing Thor, he probably doesn't want to waste his time at the Department of Motor Vehicles. So what he might do is go to a shady character, and instead of filling out a form with his information, he might just give him some money and say, hey, create me a fake ID because I need to get to the bar right now. And again, this shady character might give him a legitimate-looking driver's license, and Thor will be on his way to go into the bar. But this time, when he gets up to the security guard and says, I want to go in, the security guard asks him for his identification, his token, his driver's license. He presents it, and the security guard puts it through the machine to see if it's valid. And obviously, it's not. So he's going to see that the hologram isn't correct. There's something wrong with it. There's false data. And he's going to tell Thor to hit the road because this is an invalid token, and he can't get in. He can't do what he wants to do. So that's kind of the real-world scenario of how token-based authentication works in the real world. But now let's look at it in the context of our Angular applications. So again, we have our backend and our front end, and we have our API server that's securely behind a bunch of firewalls. Nobody can read any of the data within it. And then we have our public Angular application. And we're going to make a request to the API, and we're going to try to get a list of orders. Say we're building an e-commerce site, and we want the users asking for a list of their orders. Well, the user asks for this list, but they're not authenticated. They don't have permission to do this. So our server is going to look for a token with their request. It's not going to see one, and it's going to say, hold on, you can't do that. You're not authenticated. So it might redirect the user to the login page. It might show an error message. But whatever it is, it's just not going to fulfill the request that the user wants. So our user is going to have to log in. So again, we have our backend, our front end. And this time, the user is making a request to our authentication endpoint, providing their username and password credentials or their single sign-on credentials, however they authenticate. Our server on the back end is going to validate the user's information against the database. And if everything is correct, if the user can log in, or if the user logs in successfully, the server is going to issue a JSON Web Token that has the user's information, such as their user ID, their maybe their name, their permissions, the features that they can use. And since there really isn't an official JSON Web Token icon, I use this emoji, this Japanese emoji that stands for Open for Business. So that's just kind of a fun fact. So once the server issues this JSON Web Token, our Angular application is going to want to take this token and persist it. And it can do this in a couple of different ways. It can store the token in local storage, in session storage, or a cookie. It just depends on your use case and what you're comfortable with. But the important thing is that this token that gets issued is persisted in your Angular application. So now we've authenticated, we've gotten a JSON Web Token. We're ready to make a secured request to our backend. So now we have our application. We're going to make that request to the orders API, to the orders backend, and we're going to append the token that we received earlier to our request, and it's going to come in the format of basically an authorization header in the format of bearer and then the JSON Web Token. And now our backend server is going to look at the request, look at the headers that came with it, look for an authorization header, and extract this token. It's going to validate that the token is correct, that it was signed by our application, and if it was, it's going to look at the claims that were made in the token and see if the user has the permission to get the list of orders. And if it does, it's going to send back the list of orders. And here I just have one order number ID. But the important thing is our server validated it, our Angular application had the token, and our application works. And now any subsequent request that comes from our Angular application, we're going to want to append this token to the request. Our server is going to validate it every single time and make sure that the user still has permission, this token isn't expired. And as long as those criteria are met, we're going to return back valid data. Otherwise, we're going to return a 401 or redirect the user to the login page. Now, the really cool thing about JSON Web Tokens is you don't have to, your server, your particular API server, your application doesn't have to be the entity that that signs these tokens or that issues these tokens. So we can look at the use case where you have your application, again, your API and your Angular app, and you have a third-party service like Auth0 that's going to handle all of your authentication, so how your users log in, two-factor authentication, all of that jazz that you don't want to build because you just want to build, cool stuff and not another login page. So in this scenario, you're going to make a request from your Angular application to a third-party API, pass in the user credentials. Auth0 in this case is going to validate the user to make sure that they are who they say they are. And Auth0 is going to issue the JSON Web Token and return it back to your application. From there, your Angular application is going to take the token, again, persist it. And whenever you make a request to your backend API, it's going to append this JSON Web Token to the authorization header with an authorization header to your backend. And then your API server will, of course, still have to validate that that token came from Auth0 in this instance. And if it did, and if everything is great, it's going to send back the resource requested. Otherwise, it's going to send back an error. So that's kind of how how JSON Web Tokens work both in the real world and in theory. But how do we make them work in our Angular applications? So let's see how JSON Web Tokens and Angular work together, and Angular is really, really great at working with JSON Web Tokens just because it has so many cool features, and today I just want to go over 3 of them. So the first way we can implement JSON Web Tokens in our Angular applications is, of course, with the HTTP client library. And the way we're going to do that is I have a bit of sample code here, and my API service, my app service, and it has two endpoints. The first endpoint is a login, which doesn't require a JSON Web Token at all because we're authenticating the user. The user is going to authenticate here and then get a token. And then we have this getOrders endpoint, getOrders method, that's going to go to our API and get a list of orders that the user has placed. And right now, we're not implementing any token-based authentication. If we were to make a request to the getOrders API, it would fail because we're not appending a token. And to append a token, we could do that simply by just including the HTTP headers method from Angular Common HTTP. And then in the getOrders method, we're just going to create a new instance of HTTP headers, and we're going to add an authorization header in the format of bearer, and then get the JSON Web Token from wherever we persisted it, and in this case, it was local storage. And then finally, to append these headers to our request, we're simply going to pass in an object to our this.http get, which is the second object where we can append a series of headers, and the format is basically just add headers to the headers object. And now when we make a request to get a list of orders, this JSON Web Token will be appended to our request. Our backend server will be able to validate it and then send back the list of orders if the token was correct. Now, using the HTTP client library is very easy, it's very simple, but it could get tedious if you have 20, 30, 50 API method calls, because you don't want to repeat yourself, and you could write a helper for it, but there's a much better way to do it, and that is HTTP interceptors. And HTTP interceptors were very well used and often used in Angular JS, but they weren't around when Angular 2 came out. And we actually got interceptors back into our into Angular as of Angular 4.3. And the way interceptors work is kind of like that. But basically, the way interceptors work is we implement an interface called HTTP interceptor, which just has one method called intercept, which takes the HTTP request and then a next function, which is just an HTTP handler. And from here, we can take that request that's coming in or going out, and we can modify it. And here in this code, I'm just modifying the request. Since it's an immutable object, I can't edit it directly, so I have to use this clone method. And I'm setting headers and then adding the authorization header, just like in the previous example. But the cool thing about this is once I register this JWT interceptor in my Angular application in the ng module, it's going to automatically work for every single HTTP request that I make. And I can actually look at this request and kind of fine-tune it a little bit. So if I didn't want to append a token, in some cases I could exclude it, but just for general purposes, we can make it work this way. And then finally, we can have multiple interceptors that do different things down the line, and especially, one of the common use cases is handling errors. So what if the JSON Web Token is invalid? What if it doesn't have the right permissions? Handling it with HTTP interceptors is a much better way than trying to do it in your service. It kind of, you kind of follow that separation of concerns. You don't have so much, code repeated in your services. And then finally, the last thing I want to talk to you guys about when it comes to JSON Web Tokens and Angular applications is the use of route guards. And route guards work in the browser, so they're public. And what route guards do is they can determine whether we should load a certain page or not. And this can be a little bit deceptive because if you're using route guards with JSON Web Tokens and you're just checking to see if a JSON Web Token exists in local storage, and then if that's your check to see if you're going to load the page or not, then a malicious user can kind of figure this out and just create a fake JSON Web Token, load it in local storage or session storage, and kind of get around your route guard. Now, of course, they wouldn't be able to get any of the private data because once the HTTP request is made to your backend, we're going to know that that JSON Web Token is invalid. It wasn't signed by us, so we're going to be able to handle the error there. But route guards allow us to kind of provide the users a better experience. If they try to land on a orders page, for example, and they're not logged in, we can redirect them to the login page first. And the way route guards work is you basically implement an interface. It can be, here I'm just implementing it on the can activate state, but there's other states where we could do it, like can load and a couple other ones. But basically, we try to see, we run a condition to see if the user should be able to see this route or not. And again, all of this runs publicly in our browser. So it's kind of like a thin layer of security, but it's better than nothing, and it kind of provides a better user experience if implemented properly. And to use a route guard in your Angular application, when you're defining your routes, you simply just pass in another property. So here I'm just passing it on the can activate method or property, and then I'm just passing in the auth guard that I showed you guys earlier. So those are 3 ways that we can use JSON Web Tokens within our Angular applications to make our applications much more secure. And to summarize, so single page application security and Angular application security is mainly concerned with authorization, because we're never going to be able to store private data in the browser and ensure that it's private. We just want to make sure to see if our Angular application can have the permission to talk to a backend server. And the way that we do that is with JSON Web Tokens. And JSON Web Tokens are an excellent option for securing Angular applications. And Angular's excellent HTTP library, HTTP interceptors, route guards make it very easy to work with JSON Web Tokens and implement them in your applications. And finally, a security guard probably couldn't stop Thor from walking into a bar and getting a beer, but your server can refuse requests without valid JSON Web Tokens very, very easily. Thank you, guys. If you have any questions, you can tweet at me at Kukic Auto, and I have 2 links here. One is the bit.ly/ng spot demo, and this is actually a Stack Blitz implementation of our Auth0 Quick Start. So if you want to learn how JSON Web Tokens work in a very easy way without having to write a whole lot of code, you can follow this URL, fork the repo, just add Auth0 keys. You'll just sign up for an account, and you'll be up and running and understanding how JSON Web Tokens work. And then finally, the second link is ng-auth-series. And this was a authentication series written by my colleague, Kim, that really walks you step by step. It's like an 8-part tutorial that'll walk you through all of the authentication use cases that you might run into when building an Angular application. It's a very good read. And that's really it. Thank you guys so much.